All right, we're going to talk about the remainder theorem now. I'm not going to go into detail about examples right now. I just kind of want to talk about it and show some, give you some feedback on what's going on with the remainder theorem. We're just trying to state what the remainder theorem says about our polynomial. So essentially, we're going to be given, f of 2, and we're going to have to plug it in and do synthetic division for a polynomial. You're going to be given a polynomial, and you're going to plug in 2 here, and then you're going to get a remainder. Now the remainder tells us a lot. So if the remainder, let's just make up a remainder of 3. Our remainder is 3. If our remainder is a number other than 0, that's going to tell us that 2 is not a factor of our polynomial. It's not. Just in a sense of, if you have, let's make up a number here, 3, let's go with 7 divided by 3. Okay? 7 divided by 3 looks like this. How many times is 3 going to 7? 2 times. You get 6. You get a remainder of 1. So is 3 a factor of 7? And it has a remainder, so no. And that's essentially what synthetic division is doing here. We are dividing by 2, and once we get a remainder, if we get a remainder, then it is not a factor of our polynomial. So looking at another one, let's say we have, we're divided, let's say we give an f of negative 1. All right? We have another polynomial that we're working with. We're going to do synthetic division with negative 1, and our remainder is 0. Well, is negative 1 a factor of our polynomial? Yes, because our remainder is 0. Just like in the sense of, well, if we have 4 over 16, that's going to be 4 divided by 16. Does 4 go into 16? Yes, 4 times 16. You subtract to 0. My remainder 0. Is 4 a factor of 16? Yes, it is. Same idea going on here with synthetic division. You have to know when you do synthetic division with your number, if your remainder is 0, it is going to be a factor of that polynomial. Now, kind of going back to here, if we're showing it is a factor. If it is a factor, it's going to be the opposite of what you're dividing by. So if you have f of negative 1 and negative 1 equals 0, it's a remainder. That means we write it as, well, that means x plus 1 is a factor of our polynomial that we don't have yet. So if we find out that f of 8 has a remainder, okay, so has remainder of 0, that means we're going to write it as x minus 8 is a factor. You take what you have here and you take the opposite of that number. So 8 would be negative 8. There's a formula for it of a minus x, but we're not going to, I'm kind of just breaking it down for you so you can see the easy way. You just take the opposite of that. So let's say f of negative 4 has a remainder of 0. Okay? That means our factor would be x plus 4 would be a factor of our polynomial. You just look at it and you write it the opposite way. So if it's a minus, you're going to put x plus 4. If it's a positive, you put x minus 4. And that's what the remainder theorem is saying. In essence, the remainder theorem says you're going to get a number, you're going to use synthetic division, and if your remainder is 0, that means it is a factor. If it is not 0, then it is not a factor. That's what the remainder theorem says.